All right, guys, I am back. So the videos that I made yesterday, there were some technical issues and I could not get them to come together. So you're probably going to see like 3 different videos on this stuff. So, all right, so let's get to the point and let's go over. The first you're going to do is you're going to open up your dynamic crust distance learning hyperdoc. You're going to read directions. First thing you're going to do is watch a video on Alfred Wegener. He is known as the father of plate tectonics. So back in the early 1900s, he was kind of experimenting with the continents of South America and Africa. It was like cutting them out, and he realized, hey, these continents, they kind of fit together like puzzle pieces. And people back then in the early 1900s were like, yeah. And he's like, well, like, can you explain why mountain ranges are all mostly along the edges of continents? And they're like, yeah, mountains form because, the earth cools, and as it cools, the land the land then shrivels up, and that's how the mountains form. And he was like, well, that doesn't really make sense. And they were like, well, whatever. So he actually died, unfortunately, and you'll see that when you watch the video. And his theory wasn't looked upon until the 1950s, well after he had passed away. And in the 1950s, they had this new technology called sonar and radar, and they were able to map the ocean floor, and they mapped the Atlantic Ocean, and they noticed that there was this ridge or this rift area where the plates would spread apart and magma would come up, and they detected this magma and this heat. So they started to look into Alfred Wegener's theories, and they came up with evidence. So you're going to see that as you go through. You're going to notice that there's fossil evidence that matches up on similar fossils that were around the same time period in South America and in Africa. And if the continents were not this giant continent called Pangea, then you wouldn't have organisms around at the same time period. So as the continents start to spread apart, those fossil or organisms died away, became fossils, and then you're seeing those similar fossils. You're also going to read about the Ring of Fire. So the Ring of Fire is in that Pacific Ocean, and it's where all of the plate boundaries all meet. And when they're meeting, either they're converging and you're getting movements, you're going to get earthquakes or volcanoes, or they're spreading apart and you're also going to get earthquakes or volcanoes. So you're going to see a majority of our earthquakes and volcanoes happen at plate boundaries, or the Ring of Fire also. So you're going to look at that. So the other piece of evidence, like I said, they were looking at is that the Atlantic Ocean right now is spreading, and as it's ripping apart, the two plates are diverging from each other, that magma is coming up and solidifying. Okay, after you finish that, you are then going to, in your notes, that's the reference table. We will get to that in a second.
Mom,
you're going to get to your notes.
Where's Daddy's old plate?
I don't know where you put the plate.
I put it in my car.
Okay, so then look in the garage.
It's not in.
It's probably there. I'm teaching.
You touched it. You touched it.
Okay, I'm back. I was accused of stealing home plate. No pun intended. All right, anyway, so the next thing you do these questions in your notes and write down the pieces of evidence to support Alfred Wegener's theory. You're going to look at the 3 types of plate boundaries: convergent, divergent, and transform boundaries. You're going to answer questions after you click on this link and look at the animations to see how they work. And then you're going to look at page 5 of your reference table. And this is where I'm going to draw and explain. So your 3 types of plate boundaries, we will start with divergent plate boundaries. Okay, I'm going to use red because magma. And so Mid-Atlantic Ridge is this area where the Atlantic Ocean right now is moving very slowly, but it's moving. It's breaking apart. And as it separates, you can see my drawing. As it separates, the magma comes up and solidifies and forms like this higher area, kind of like a mountain ridge, a higher area where magma comes up and pushes out the ocean floor.
Mom, there's no bees.
There's no bees. Can you please stop?
I saw some stung
Okay.
Bees.
Okay. There's no bees. Go away.
I saw some stones.
Okay. Anyway.
Are they the mosquitoes?
They're not mosquitoes. They're just bugs. Anyway, so this ocean floor is spreading apart. We have ridges.
I found it.
We have ridges in the ocean floors, like the Pacific Ocean right here. You could see that this between the Antarctic plate and the Pacific plate, these two plates are diverging and moving apart. So you can see that in your key right there. Divergent means to spread apart, and as it spreads apart, magma comes up, solidifies, and creates new ocean floor every single day. The other plates we want to look at, or type of plate boundary, is your convergent plate boundary. We have these boxes. And if you go down to the map key, you're going to see the boxes mean the overriding plate. And the non-boxes are your subducting plates right here. So let me show you what happens. So the two plates, they're going to collide. But if you were the less dense plate, which is the land plate, because remember on page 10, land has a density of 2.7 because it's mostly granite. And the ocean has a density of 3.0 because it is mostly basalt. So as these two plates are colliding, your land plate, which is land plate less dense, will ride over ocean plate more dense, subduct. Subduct means to go over. And as it subducts, that land plate gets driven on top and you form these mountains. But also, as a plate subducts, it gets pushed into the interior of the earth where it's very, very hot. And subduction causes the melting, the partial melting of that ocean floor. So you're going to get these volcanic mountains that form along the edges of where an ocean plate meets a land plate. Okay, so sometimes you're going to have an ocean plate like this over here colliding with an ocean plate over here. And it kind of just depends on the makeup of the rock, on which one becomes the overriding plate and which one becomes the subducting plate. But again, you're going to get volcanic mountains, and you're going to get a chain of islands like the Aleutian Islands or the Philippine Islands or Japan. So they all form the same way when two ocean plates collide. There's one difference though. If you have two land plates that India and Asia collide, or China over here, there is no subduction because the two land plates are equal in density. So they push the two plates up and they form the largest mountains in the world, the Himalayas or Mount Everest. Okay, so Mount Everest is found there. There's no subduction. And the other thing I want to show you is a transform fault. A transform fault is where two plates just rub against each other and there is no subduction, so there's no magma that's formed. It's just tension released by earthquakes. So you have your San Andreas fault, which is a transform fault. One plate moves one way, the other plate moves parallel in the opposite direction. You might see arrows, or you might just see a line like the one I'm highlighting. Or if you can't see that, if we go on to the other side of Africa, there's another line here. That's your transform fault as well. I want you to keep in mind that the Earth is round, so Africa will connect to Africa over here. So if you have any questions and you can't find the east coast of Africa, you need to look on the other side of the map. You also have complex boundaries. Complex boundaries are areas where geologists they're not really sure yet. They think that this might be a transform boundary, but they're not 100% sure. They think this might be a divergent boundary, but they're not exactly sure yet. So complex means not sure, uncertain. All right. And then hotspots, we'll get to that in a different lesson coming up. Other thing I want to go over. Okay, there are actually 3 types of convergent boundaries. So I went over it a little bit on page 5. You have ocean to ocean. So when two ocean plates collide, one will subduct, one will be slightly more dense than the other, like in Japan, and you will get volcanic mountains. Another is continental to ocean. The continental plate is always less dense because it has a density of approximately 2.7, and the ocean plate a little more dense, density of 3.0. So your ocean plate will be the subducting plate, and as it goes under, like I said, you will have partial melting, which creates magma, and then that will fill up this mountain, and you will have volcanic mountains. In a continental to continental plate boundary, like I said before, the two land plates collide. There will be no partial melting, no subduction, and you will get the largest mountains in the world. You will get mountains. They will not be volcanic. Okay, so those are your notes for today. Please go over them. Watch the videos too. They were kind of interesting. On Friday, I will do a mini lesson on this. After plate boundaries and continental drift, we will move into seafloor spreading and hotspots for next week. And that is it. I will see you guys soon.